Okay. All right, why don't we get started? Hi, everyone. My name is Roland. I'm with Heimdall Data. I'm accompanied here with our architect, Eric Brandsberg, and we're going to be providing an exciting webinar here that is very unique in industry in terms of its functionality for Postgres, and it's going to be very pinpoint targeted. The webinar is about advanced connection pooling and Active Directory support. What we're going to do is the agenda for today is you're going to learn how to use Postgres, learn how to reduce Postgres resources with advanced connection pooling, with per user and global connection control limits. And secondly, you'll learn how to simplify database access management with Active Directory and LDAP and with group extraction for Postgres. Afterwards, we'll leave the remaining 15 minutes for question and answer to answer any questions you may have or inquiries you may have. So we're first going to give an overview on these two pieces of functionality. Eric will provide a technical demo on how it works, and we'll leave the remaining section for question and answer. First, as a background, the Heimdall proxy sits in front of Postgres, and we offer two software options. It can be run as a JDBC driver that sits in between the application and the vendor JDBC. The other, if you're not running a JVM, our proxy can run as a database proxy that can be on a separate proxy tier or on the application server itself. This proxy is the component that provides the advanced connection pooling and provides the data access management. We're not going to go into detail of the other features that we can support, but I'll just sort of whet your appetite on some of the things that we can do. If the application is on the top here, it's going to go through our proxy platform and hit any of these Postgres data sources. It could be in Amazon, it could be RDS, Aurora, Redshift, Pivotal, Greenplum, anything that's a Postgres derivative, we can support. Now, the things that we're not going to talk about, but let me just gloss over today, is we can support automatic query caching, read-write split, connection multiplexing. For data warehousing, we can do batch processing. So we can aggregate DML, singleton DML, and batch them together under a single transaction to your Postgres database. We support automated failover. And then what we're going to talk about today is authorization and authentication. So just to whet your appetite, there's a lot of modules that we can provide for the backend developer, for the DBA, but we're only going to talk about the two blocks here on the right-hand side for this webinar. So the way that you can deploy our proxy, again, is two ways. The first way is a centralized proxy tier. You can have multiple proxies for which the application instances talk to. And these proxies are being controlled by a central console. So the deployment is quite simplistic. There's a control plane, which is the central console, and there's a data plane, which are the proxies. And they speak on behalf of your Postgres backend. So that's centralized. The distributed model is it takes our proxy and it's installed on the application server itself. So if you have 3 application servers, you have 3 proxies. It's a one-to-one mapping. And this is particularly advantageous for caching because you're bringing the data one step closer to the user. So you're serving out SQL results from an application perspective. So this is distributed in a scalable way, but you can also have it as a central proxy tier as well. Okay. So now we're going to be entering into the talk about enterprise multi-user database requirements. And I'm going to hand this over to Eric to go over the rest of this presentation. Eric?
Oh, yes. Before we continue, are there any questions at this point? Okay. If you can stop sharing, Roland.
Eric, did you want to go over the slides?
Yes, can you hear me?
Yeah.
Were there any questions? I wanted you to, oh, sorry, I got it. Okay, so let's get into the details of the multi-user database requirements. As many of you are probably quite familiar, in particular in relation to Postgres, the general use case that most people have is that they have a very small number of users that are connecting to the database. Often it's one primary user, that's the application user, and then possibly an admin user and maybe a couple of other support people. What it generally does not happen is that you have hundreds of users that are connecting to the Postgres database at the same time or even at different times of the day. What we're going to be talking about is how to support such an environment effectively while using Postgres or any Postgres derived databases. And that would include Greenplum, Redshift, Aurora, or Citus. Next. Okay. So to begin with, one comparison that we want to do is something comparing to something that most people already have familiarity with, and that is PG Bouncer. It also acts as a proxy type of device, and PG Bouncer, in theory, for example, supports LDAP capability. But what you're going to find is that if you start using lots of users, then PG Bouncer's functionality starts to degrade dramatically. So just to start off with, what we call multiplexing would be considered transaction pooling in the PG Bouncer world. We're not going to talk about statement level pooling because it really doesn't matter. If you're using transactions, it's transaction level pooling. And if you're not using transactions, then if you set transaction pooling, then you're getting statement pooling anyway. So statement level pooling is kind of redundant. You just use transaction pooling and either case works. And both Heimdall and PG Bouncer support that. But it's the differences in how it works behind the scenes that really makes the big difference. The second part is per user pooling. Let's talk about how PG Bouncer works. If you configure connection pooling in PG Bouncer, and then you connect with two users, what it does is it creates two connection pools. If you set your connection pool to allow 100 connections, then user 1 will be allowed 100 connections, and user 2 will also be allowed 100 connections. There are no shared resource controls to say both users should have no more than 100 connections unless you're limiting the number of total connections PG Bouncer itself will accept, in which case you're breaking the point of even doing multiplexing. Heimdall, however, has both global connection pool limits and per user connection pool limits. And you can even change connection limits on a user by user basis on the fly. So you can set policies that say user A, use pool A, or use up to 10 connections. But user B, which may be your application server user, it could have 100 connections. So as a result, you're controlling both at a total pool size and individual user pools. The net result is you can actually constrain the number of connections to match what your connection limit is on the database. With PG Bouncer, when you're dealing with multiple users, you can't do that. Additional functionality in comparison with PG Bouncer is that Heimdall has a multi-port listener, so you can specify multiple ports, say port 5432, 5433, and 5434, and then you can actually change behaviors between different ports on an as-need basis. So that would allow you to say, for example, have your users connecting on port 5432 that are doing analytics or reporting. Your application is connecting on port 5433, and the application would not have multiplexing enabled, but your users that have a tendency to leave connections open and sitting idle would have multiplexing enabled. At the same time, you're still maintaining one connection pool as an overall behavior, and you can still maintain control over how many connections each set of users are allowed to have. Next part is that with PG Bouncer, at least the newest version of PG Bouncer, it relies on PAM, or pluggable authentication modules, to do LDAP support. As a result of that, you have to go into your operating system, you have to configure your LDAP configurations, etc. And that means that for no matter how many instances of PG Bouncer you effectively have only one authentication domain. With Heimdall, we can set up multiple virtual databases that can point to different LDAP configurations and use them on the fly. And it's very easy to configure, and I'll be demonstrating that in a little bit. Further, because your PG Bouncer is simply using PAM for its authentication, it doesn't have any sort of awareness on LDAP groups. So you can't, for example, do anything to say, if they're a member of the VIP group, give them more connections than if they're simply part of the finance group. With Heimdall, we have group awareness so that you can extract your LDAP groups and then apply policies based on those groups. And that goes into the final line, obviously, of LDAP group policies. I'll roll in next. Okay, so I'm going to get into this a little bit more, but this is just a quick set of screenshots that show how easy it is to do the configuration. Next. Okay, so we've kind of gone over a lot of this with already, but basically PG Bouncer was designed for a single user. It really doesn't have the capabilities for dealing with large numbers of users, not when you're dealing with connection pooling, not when you're dealing with authentication. You just can't control the size, and since Postgres is optimally handled with a relatively small number of connections, PG Bouncer very much degrades under load when you try using it in a true multi-user environment. Next. And again, we've gone through this, but to highlight, Heimdall allows different users to have different connection pools, but as a whole, you still have connection limits. And that's a very important point in order to ensure that you don't have outages because too many connections are being used on the back end. Instead, you queue any new connections and more aggressively time out idle connections when they're no longer used on the back end. Okay, next. Okay, and I'll get into this as well. But what this is an example of the show pool command. Since Heimdall is behaving as a proxy, we can intercept commands that are going through the proxy to the database. So the show pool command gets exposed as if it were running on the database, but it's actually executed and the result is returned by Heimdall itself. But this means that you can use pSQL in order to show the connection pools, what users are using the connections, how many are busy, how many are idle, what type of turnover you have on your connections, etc. We have a number of commands that are embedded and processed in the same way. in order to allow you to see what's going on. And we even provide aliases that, if you're familiar with other databases, are convenient, much like the / commands within pSQL. So, for example, when you run through us, show databases, we'll give you a list of the databases, show tables, etc. Next. Okay. So we've kind of discussed this. Multiplexing, aka transaction statement and pooling. It's supported both by PG Bouncer's Heimdall, but there are a couple more features. The first one is delayed transactions. If you've ever worked with a lot of application frameworks, ORMs, you may find that many of them do everything in a transaction. You simply can't run even a select without starting a transaction, then you do the select, and then you can either do a commit or a rollback. Starting transactions when they're not needed can become particularly costly in some environments like Greenplum. As an analytics multi-processing database, if you start a transaction, it has to actually enlist all the nodes on the back end, all the data nodes, not just the master node. Takes a long time to start the transaction and takes a long time to complete the transaction, even if you don't need the transaction. With Heimdall, delayed transactions, when enabled, what it does is it actually waits to start the transaction until a DML is executed. The DML triggers us to actually start the transaction. And then it will continue until it's either committed, rollback, or otherwise completed. This is important just to improve performance, but it's also important when you're dealing with cache rules within Heimdall, because it means that you can cache more content, and it also allows multiplexing with transaction level pooling to operate more effectively. Okay. Again, also the rule-driven multiplexing, you can change things on the fly. If a user executes a command that you know does not work effectively with multiplexing, for example, a set command, you can literally change a state of multiplexing from being on to being off at that moment, such that the application continues working the way that it would expect. After the user frees up the connection, it would close out the backend and release the connection because it changed state. Next. Okay. As part of our connection pooling logic, we are built on a relatively popular, or possibly the most popular, connection pooling library that is in use, and that is the Apache Tomcat connection pooling library. However, since the Apache Tomcat library did not have much in the way of support for multiple users, we've customized the library, but at the same time, we've maintained a full complement of the various options that are leverageable in order to tune how connection pooling is done. This allows you to make connection pooling work in situations where it otherwise would not work for other applications. I believe that's the end of the slide deck, correct, Roland?
Yeah, that's it. Would you like to entertain any preliminary questions?
Yep. So before we actually get into the demo, we're open for questions, and then I'll get into the demo to show some of the functionality as well.
Yeah, we have one here.
And feel free to also type it in the chat window as well.
Yeah.
Yeah, okay. So just a quick question about OpenID Connect. Any support for that upcoming?
If it has an LDAP interface, we can leverage it. We can, if there are customer requirements, integrate with other authentication engines as well. The next one that we're most likely to integrate, just based on demand, has been actually in Amazon to integrate with IAM roles. But we can tie in with almost anything. Okay, so just let us know your requirements, and we can explore that while we explore the other functionality that you need.
I
Yeah,
had a
it sounds
question
like
about,
if you're, oh, sorry, just to sort of with a closing comment there, if you're going to do the Amazon IAM stuff, it sounds like you're probably doing authentication with OpenID anyway there. But yeah, we'd like to learn some more about that. I guess we'll contact you offline.
Okay, that would be great. Next question.
yeah, I had a question about delayed transactions.
Yes.
So in the example you gave with Greenplum, the cost was expensive in terms of creation of transaction. In the case of in the use case I'm thinking of, the cost is prohibitive as the number of DML statements ascends to a certain number. So what I'm wondering is, how many knobs and levers do you have for that kind of mechanism? So let me just throw a simple case. We have a steady stream of inserts going into a database. The only really DML that we're interested in is inserts in this case. Updates we'd allow to flow through, deletes we'd allow to flow through. But the inserts we'd want to gather and say at a certain threshold, we'd want to trigger a command to do something with that.
Okay, great question. A little bit out of the scope of what we're expecting here, but something that's very interesting as well. We have what we call DML batching as a capability. And what we can do is, let's say you've got an ETL stream that's sending in lots of data as singleton DMLs. We can pull those DMLs out of the normal insert process, and depending on how it's set up, either spoofing or not spoofing that the DML was completed to the application side. We then batch that up into a maximum of a batch size. And then we can even, if it's a bunch of inserts against the same table, we can rewrite all those individual inserts into a multi-row insert. And then we can either, with or without the rewriting, we can wrap that in a transaction as well. In the case of Greenplum, wrapping a bunch of singleton DMLs in a transaction alone provides a huge performance improvement. In the case of Redshift, you have to rewrite the statements into a single insert in order to get a huge improvement, but we support both.
Very interesting. Thank you very much. I think Robert and I will like to talk to you guys offline so we don't stall up your demo here. Sorry.
No problem. Okay, but we're very much a Swiss Army knife of functionality where there's a large number of pieces. And in dealing with an analytics type of environment, like what you're going to get in Greenplum or Redshift, if you're going to expose those to a large number of users, that's where like the Active Directory really comes into play. But all these other features come into play as well.
Yeah, just drop us a line at info@heimdalldata.com.
Yep.
All right.
Any
Eric.
other questions before I start presenting some demo stuff? Okay. I am going to share, make sure that I'm getting the right screen. Okay. So let me talk about the demo setup that I have here. I have an application that's running called Udo, which is a Postgres-based e-commerce / multi-use type of application environment. And what I'm doing is I'm running a bunch of background traffic on it just as a traffic load. But what I have here is a configuration, and for our proxy, what I have is it's set up to use Active Directory for authentication. All you have to do is point to the LDAP or LDAP-S URL, set up your search domain, provide user credentials so that we can connect to the LDAP server. If you want to filter the groups that are being returned, you can then filter the groups. And what we do is basically we connect and make sure that the user can bind that is being provided at the Postgres level, combined through, and when bound, we can retrieve, or that user has at least one group returned. As long as we then have a group, You then have the option to do a synchronization against a database, where we connect to the database using a username and password. This would be your admin user and password. And then we can execute a synchronization command that will actually inject the user that authenticated into LDAP or Active Directory into the database itself. And this sync user function can be customized based on your environment. So it'll be passed the actual user and password credentials that were authenticated against LDAP. And then when we do the group extraction, the groups themselves will also be passed to the backend database. So it can do whatever it wants in order to do the authentication and adjusting the roles for that user on an on-need basis. And the synchronization is set up such that it won't be called for a given user any more than 5 minutes unless their credentials change. As the LDAP information itself is cached for up to 5 minutes. But if their credentials change, or after 5 minutes the LDAP groups are changed, then the database, the synchronization will be called, routine will be called for that user again, so that you can tear down whatever roles they may have been a member of, and set up new roles based on the new information. Okay, and I know that there's a lot to take right here, so let me stop for any questions right here at this point. Okay, to explain on the database side how this works, we have the function.
Well, maybe there's a question there. I mean, so that plays into being able to revoke, right?
Correct. So basically, anytime the credentials change after a 5-minute cache period, and the user is either denied or their roles change, then we will resynchronize. And the idea here is that if the user's role doesn't exist, we'll create the role. We can revoke membership as needed. Actually, this is something that I still need to expand out on, is the removing of old memberships. But new memberships are then added back here. So as a user's role change, let's say they move from the finance group to order processing or whatever. They may have access to different data based on their LDAP groups. And this will allow you to tie their actual data access to LDAP. So you won't have to manage their group membership or even their authentication credentials on the server anymore.
Okay, yeah, that's what I wanted to know about the role change thing.
Yes. So this is set up such that as their role changes, their permissions within the database can change as well on the fly.
Great, thanks.
Okay.
In terms of the list of groups that's passed, is it the full distinguished name, or is that available if we wanted to pass the full distinguished name? I see you have like LDAP groups of probably a comma separated list of CNs that correspond to the groups or SAM account name.
Yeah. So let me give you an example. A default LDAP or Active Directory setup where you don't make any changes, this is what will be passed through. Okay, does that answer your question?
Yeah, I think in some cases we're going to have, for example, a lot of groups, and some of the names might collide, so we may need distinguished names passed.
That's something that we can work with you on.
Cool, thanks.
Okay. We're very flexible and ready to deal with unique customer requirements as they come through. Okay, so this is an example of a sync user call. This is exactly what would be called with the Odoo application as it's generated. And with that example, this is what it's basically trying to execute. It's trying to do an alter role with a password. It's doing the grant of the user, which is already in existence, to the user Odoo. creating role, obviously it already exists. Then it's granting the user's role to Odoo. And again, it's already a member since I've executed that before. So the net result of this is that you'll be able to maintain everything in LDAP and not worry about it. Okay, which can I get your feedback on the importance of this as you're migrating, in particular from anybody that's trying to migrate from SQL Server? Anybody have any comments on that? Okay. The next piece is the multiplexing. And as you can see, we have this is the name of the global pool that's being used for the virtual database. And that's actually on a per server basis. So if you have an active a read-write server, and then you've got a read-only server, you'd actually have two pools representing each of the individual servers that are being used. Then for each combination of a database and a user, you have the number of busy connections and the number of idle connections. As the number of busy connections in sum total approaches the number of total connections that you allow, what you'll find is that we will start timing out idle connections for individual users more aggressively on a proportionate basis. So if somebody has 20 idle connections and another user has 5 idle connections, we may close 4 connections for the first user and 1 connection for the second user in order to free up, in order to make room for more connections to be established in the database. But we track everything on an individual user and database perspective. So this allows you full control over how many connections a particular user can access when accessing a database. Okay, and then you can see how many are actually created, and you can see very few connections have been created since they started everything, but the number of borrowed connections is absolutely huge, relatively speaking. So basically, we're just reusing these connections over and over again, and the database doesn't have to worry about establishing them and starting up new processes in order to deal with them. Okay, now if you notice here, we have 4 connections that are active. Now, if we go back to my dashboard, we actually have 4 threads generating traffic against this Odoo application, and there are 4 worker processes that are starting. And in most cases, if we do this, we're going to see 4, but occasionally you're going to see 3 active connections because only 3 connections have active queries on them at a given moment. What I'm going to do is I'm going to come over to these rules, and I'm going to enable this cache rule. Commit. And what we're going to see is that caching is going to go up to about 90%. Now, because so many queries are being serviced from caching, what that means is that the multiplexing capability is going to be able to free up backend connections such that most of the time, no connections are active, and we can actually close those connections if we need to. So if I do show pools now, you can see that the Odoo user that did have connections now has no active connections, and those connections are basically just sitting idle. And we're going to leave those idle as necessary. There's no point in closing an idle connection unless we start running out of connections, and then we're going to start closing those out in order to free up room. So again, with the multiplexing capability, you could have hundreds of users that are technically connected to the database and think that they're connected to the database, but you may only have 20 or 30 actual active connections at any given moment. Okay, it's all based on who's actually doing something, and you'll be able to see that here. And then you can also do show connections, and this shows you what's happening from the proxy perspective. Let me see if I can capture it doing something. Actually, let me turn off the caching. Commit. Okay. So this now tells you what URL is being used to establish the connection. And this is a hash value of the query, which can be looked up within our logs, but for privacy reasons, it's not being shown. Okay. If I logged out /q and logged in as the Udo user, okay. Anyway, in theory, this should have shown the actual query, but I will look that up. But this gives you more information on what's going on all the connections, etc. Any questions? I'm going to open this up to any questions in general, not just on the demo as well.
Do you have any metrics for your activity, like Prometheus stuff, or how do we monitor your thing?
Okay, there's a lot of different things that we have. First off, we have our analytics tab that shows you actually what queries are going through, the cache hit rates on the particular queries, how much time it took when served out of the cache versus when it came out of the database. We can actually expand out the query, which gives you a better formatted and easier to read version of the SQL query. Tells you what tables are being done, and we have actual execution plan extraction as well. So that's done on a periodic basis and gives you kind of post-mortem view if you wanted to look up what was happening in the past to see what the query plans look like. Okay, we have our dashboard in order to show the behavior and what's going on, including things like the memory. We also integrate with AWS CloudWatch and Cloud Metrics. So each individual proxy feeds a selection of metrics directly into CloudWatch. I'd have to pull that up. That would take a few minutes to do that. But that allow you to monitor things from a long-term perspective if you're in an Amazon environment. We also have detailed logging capability. So all the queries, you can, if you wish, log. If you look at the rules, you have the ability to do log sampling. So we're only logging 1 out of 100 queries right here. But you could log all the queries if you wanted to. So there's a lot of different things that you can do from a monitoring perspective. And again, as I said, we're willing to entertain customer requests in order to expand out almost any aspect of our behavior. Monitoring is one of them.
Okay, but I mean, you're Java-based, so JMX presumably is.
Yeah, we are Java-based, and there's a lot of stuff that you can do with that as well.
Okay.
Okay. Any other questions? No more questions? Okay. I would like to call out that we are available on the AWS Marketplace. We're available on the Azure Marketplace. We're also available from PivNet if you're a Pivotal customer. And we also have free download to install into either on-prem or cloud instances with a single line installer as well onto pretty much any version of Linux. So we're very easy to get online. We provide a 30-day free trial for you to test. And we provide free POC support during that period in order to help you get online, verify that it will work for you. And if you have any questions or problems, we'll help to take care of you. If there are no other questions, then I'd like to conclude and thank everybody for attending.
Well, just to clarify, you're going to send us the slides, and I guess we'll get your email that way.
Okay. What I'll do is we'll coordinate with JD in order to send out the information for everybody. I will also take the recording of this presentation, and I will post it on our YouTube channel. So if you go to YouTube and simply look for Heimdall Data, we will be posting the recording there as well. Okay. Any other questions? Okay. Thank you, everybody, for attending, and hopefully we will be hearing from at least a few of you moving forward.
Yeah, great presentation. Thank you. I
Okay.
appreciate it. And to the organizers as well. That was really helpful.
Okay. Thank you. Bye.